In this unit, we're going to discuss free fall. Gravity causes objects to accelerate downwards once they begin falling. Free-falling objects are only affected by gravity. So for now, what we're going to do is we're going to imagine that there is no air resistance affecting objects that are falling. Eventually, later on, we'll talk about what the air resistance does to a falling object. It's customary to use the letter G to represent the acceleration due to gravity. And when we talk about the acceleration due to gravity, it's a constant. On Earth, that value is 9.8 meters per second squared. What we're going to do for our purposes is we're going to round that number off to 10 meters per second squared. What that means is every second a falling object will be moving 10 meters per second faster than the second before. The instantaneous speed of an object from rest can be determined by using the following equation. V equals gt, where V is going to equal the instantaneous speed or velocity, typically in meters per second. G is going to stand for our acceleration due to gravity, which is 10 meters per second squared. And T is going to equal our elapsed time. So let's look at an example. What would be the instantaneous speed of a falling object 4.5 seconds after it drops from rest? So we'll start by writing down our equation. Since we're trying to find the speed, our equation is going to be V equals G times T. Our V is our instantaneous speed or velocity, and in this case, that value is x. The G stands for our acceleration due to gravity. It's not going to be given to us in a problem because it's a constant, and we need to know that that equals 10 meters per second squared. T stands for time, and for this particular question, our object is falling for 4.5 seconds. Now we'll substitute those values into our equation. So we're trying to solve for our velocity. We'll plug in 10 meters per second squared for our acceleration. We'll plug in 4.5 seconds for our time. Notice that one of the seconds will cancel out and we're going to be left with meters per second for our units. So x, which is going to be our instantaneous speed, will be 45 meters per second. So if an object is in free fall for 4.5 seconds after that period of time, it'll be traveling 45 meters per second. Let's say that an object free falls for 1 second. Since its acceleration due to gravity, at the end of that 1 second, it will be traveling 10 meters per second. Since the acceleration due to gravity is 10 meters per second squared, each second our object will be traveling 10 meters per second faster than the previous second. If we want to calculate the average speed during that time, we would calculate it the same way we would calculate any average value. We would add the initial and final speeds and then divide by 2. So in this particular case, we're starting from rest, so our initial speed is 0 meters per second. We're ending at 10 meters per second. So we would take 0 meters per second plus 10 meters per second, divide it by 2, and the average speed in the first second of free fall is 5 meters per second. This means that the average speed during the first second of free fall is 5 meters per second. This leads us to the equation used to calculate how far an object has fallen in a given amount of time. Our equation is d equals 1/2 gt squared, where d equals our distance, in meters typically. G is our acceleration due to gravity, which again is a constant on Earth. We're going to consider it to be 10 meters per second squared. And T stands for the time. So here's an example. If an object takes 3 seconds to hit the ground, how high above the ground was the object when it was first dropped? So we want to find a distance. So we've got distance equals 1/2 gt squared. We're trying to calculate the distance, so that would be our x value. Again, the acceleration due to gravity is not going to be given to us in the problem. We just need to know that on Earth, that value is 10 meters per second squared. The time that it takes for our object to hit the ground, in this case, is 3.0 seconds. So we can take these values, plug them into the equation, and we'll be able to calculate how far above the ground the object was when it was first dropped. So we'll put x in for our distance. We've got 1/2. For g, we'll plug in our acceleration due to gravity, so 10 meters per second squared. For our time, we'll plug in 3.0 seconds, and we're going to square that value. So we know from our PEMDAS rules, the first thing we'll do is take care of our exponents, and then we'll do the multiplying afterwards. So we've got 1/2 10 meters per second squared times 3.0 seconds squared. So we're going to square the 3. That gives us 9.0. And we're also going to square the seconds. So that's going to give us seconds squared. Notice that this time, our seconds squared are going to cancel out, and we're going to be left with meters. So the next thing we'll do is take our 9 and multiply it by our 10. So we're going to have 1/2 90 meters, since our seconds squared cancels out. And then 1/2 of 90 gives us 45 meters. So if it takes an object 3 seconds to hit the ground, it must have been 45 meters above the ground when it was first dropped. We can take this equation for distance and we can algebraically manipulate it to get to time. So let's practice doing that again. We've got distance equals 1/2 gt squared. If we want to get t by itself, the first thing we're going to have to do is get rid of the 1/2 and get rid of the g. And then finally, we're going to have to take the square root. So we're going to divide by 1/2 and we're going to divide by g. We know whatever we do on one side of the equation, we need to do the same thing on the other side. So we're going to divide by 1/2 and we're going to divide by g. That's going to give us t squared equals d over 1/2 g. Now, we don't like having fractions in the denominator, so we'll multiply by the reciprocal of 1/2, which is 2. So t squared equals 2d over g. And then we'll take the square root of both sides to get t by itself, and we're left with t equals the square root of 2d over g. Again, the t is going to stand for the time it takes. D is going to stand for the distance that the object free falls. And g is going to stand for our acceleration due to gravity. which is that 10 meters per second squared. So our last example in this session is going to be how long will it take an object to fall 20.0 meters? So we'll start with our equation. Time equals the square root of 2d over g. In this case, time is what we're trying to solve for. D is our distance. So for this particular problem, we've got 20 meters. G is our acceleration due to gravity, which we know is 10 meters per second squared. Now we'll plug in our values. So x equals the square root of 2 times our distance, which for this problem is 20.0 meters, divided by our acceleration due to gravity, which is 10 meters per second squared. We're going to do the math inside that radical sign first. So 2 times 20 is 40. 40 divided by 10 is 4. Now, when we look at the units, the meters are going to end up canceling out, and we're going to be left with seconds squared. So now we're going to take the square root of 4 and the square root of seconds squared, and that's going to give us a value of 2 seconds. That means it would take 2.0 seconds for an object to fall 20.0 meters. If you need to, you can go back and listen to all or parts of this video again to make sure that you understand how to do the problems that involve free fall.